Okay, so we've all seen the incredible things AI can do, right? From creating stunning art to writing poetry. But how does it actually work? How do we get from some super complex idea in a research paper to a tool that you or I can actually use? Well, in this explainer, we're going to pop the hood and take a look. So, to really get this, we're going to break it all down. We'll start with the big one. How does an AI even learn in the first place? Then we'll talk about where this AI physically, well, lives. After that, we'll see how it shifts from being just a tool to a real teammate. And finally, we'll look at the modern toolkit that puts all this amazing power right at your fingertips. All right, first things first, how does an AI actually get smart? Let's get into the brain of the whole operation. And what's so cool is that it's all about the AI teaching itself, using this really powerful but surprisingly simple idea of trial and error. And that method has a name, reinforcement learning, or just RL. Now, that might sound a little technical, but trust me, you already get the concept. It's basically learning by doing. Think about training a puppy. When it sits, you give it a treat. That's a reward. When it chews the furniture, no treat. RL is the exact same idea, but for a machine. It just gives the AI positive feedback for good decisions, which slowly guides it toward mastering whatever task it's been given. Okay, yeah, this slide looks a little intense, but don't get hung up on the math here. Just focus on the shapes. These are basically just different strategies for learning. Monte Carlo, on the left, is kind of like playing an entire game of chess. And only at the very end, when you see if you won or lost, do you decide if your first move was a good one. Then there's temporal difference in the middle. That's more like checking in after every couple of moves to see how you're doing. It learns on the fly. And on the right, dynamic programming is the super planner. It tries to think through every possible outcome from the very beginning. The point is, they're all just different ways for the AI to figure out which of my actions gets me the best reward. And all of those fancy strategies, they all come down to this one simple but really powerful loop. The AI observes where it is, it takes an action, it gets a reward or a penalty for that action, and then it updates its strategy. The real magic isn't just one trip through this loop. It's that an AI can do this millions of times, getting just a tiny bit smarter with every single try until it's an expert. But of course, all that learning has to happen somewhere. You know, an AI brain needs a body to run on. And as you're about to see, that body can be anything from a massive room-sized data center all the way down to a tiny chip that fits on your fingertip. These charts are awesome because they show there's no single best place for an AI to live. It's all about trade-offs. So follow the blue line for CloudML. See how it shoots way out on computing power? It's an absolute beast, but it also has high latency, which is that annoying delay you get. Now, compare that to the red line for TinyML. It's a champion of low power and privacy, amazing for small gadgets, but its raw computing power is way more limited. So you're always making a choice, balancing raw power against things like speed, size, and even privacy. And you can see these trade-offs playing out in the real world. On the left, that's EdgeML. You've got systems like smart farms that can process data from drones right there in the field without needing to send anything to the cloud. And on the right, that's a TinyML kit. I mean, it's small enough to fit in your hand, and it can run AI on a tiny battery for months. It brings intelligence to the smallest possible devices. So we've got the learning theory, and we've got the hardware. What does it actually look like when this all comes together in a product you can use? Well, what's happening now is that AI is becoming less of a simple tool and a lot more like a teammate. This idea is just captured perfectly by the folks behind Claude Code, which is an AI coding assistant. They literally tell their users to talk to it like you would a helpful colleague. And that one sentence just reframes everything. It's not about you giving commands to a machine anymore. It's about collaborating with a partner. And this teammate is incredibly helpful. It can take on all those tedious but really important jobs, like cleaning up messy code, writing tests, or updating documentation. And that frees up human developers to focus on what they're truly great at, coming up with creative solutions and building new things. It's a massive force multiplier. And the best part? It's so simple to interact with. All of that power is hidden behind these really intuitive, simple commands. So for instance, instead of spending hours digging through confusing error messages, you just type /doctor and the AI literally diagnoses itself for you. It's all about turning these really complex problems into dead simple solutions. Which brings us to what I think is the most incredible part of this whole story, this amazing bridge that's been built from pure abstract mathematics to something that honestly feels like magic. Just look at this. On the left, you've got the raw power source. It's this dense, abstract, mathematical formula from a research paper that maybe a handful of people on the planet truly understand. And on the right, you have the light switch, a simple, natural language command that anybody can use. All of that intimidating complexity on the left is what makes the simple, incredible utility on the right possible. And that, right there, is the story of modern AI. So, we've gone all the way from mind-bending math to powerful hardware to a helpful colleague that lives in our toolkit. The technology is here, and it's getting easier to use every single day. So the only real question left is the one right here on the screen. What are we going to build with this new teammate?